Okay, here's example 2 on page 155. We'll also do the checkpoints at the end. Um, Now, this one, once it gets done, kind of looks like a no-brainer, but at the start, it's got two equations that, well, it looks like we could probably do something with those. So we're going to actually graph these. You might play around with these with substitution and linear combinations, but we're going to go ahead and set these up to graph. So it's going to look a little bit like this. The first thing we have to do is we have to convert both of these into slope-intercept form. That's probably how we're going to graph it. So if you do the first one, this is kind of an easy one to see. It comes to y equals negative 3x minus 1. That's from subtracting 3x here and subtracting 3x right there. Now, when you do the second one, I want to give you just a moment to pause the video and do this. Go ahead and solve this one for y. In other words, convert it to slope-intercept form. Go ahead and pause the video right now and convert that one. Okay, so here's what happened when I did this one. It came out to y equals negative 3x minus 1. Now, since these came out to be the same exact thing, what they do is they actually, when you plot them, you'll find that they represent the same line. So every point on the line is a solution. And I think it graphs something, if you graphed it, something maybe like this. So once you graph that graph the first line, you see the other one basically is just going to land right on top of it. Now, had you done it with linear combinations and you multiplied the top one, the top equation, left the bottom one alone, but multiplied the top equation, here's what you would have seen. You would have seen that this came out to a positive 6x. This came out to 2y. And this came out to negative 2. Now take a look at this. Had you multiplied that first one, I think it would be by 2, multiplied all terms by 2, you'd see that everything here cancels out everything else. So this cancels this out, this cancels this out, this cancels this out. It comes to 0 here, 0 here. Now if you ever see that, that also means that, that these are not going to do anything other than overlap. So here's what would happen here. The variables are eliminated, and you're left with a statement that is true regardless of the values of x and y. It doesn't matter what you put in for x and y, it's going to work. So the system has infinite solutions. So a clue for this one is really either do they lie on the same, do they lie on top of each other, the two lines, meaning that every x and y is the same for both equations, or does it come out like this if you try the linear combinations? Does it come out where everything crosses itself off and it comes to 0, 0? That'd be a clue that it has infinite solutions.